Hello, this is Algebra 2. This is Chapter 7, Section 4, the second part. Here we're going to look at a few things related to logarithms. Let's see here. First we've got what I call logarithm evaluation tricks. It's worth reading this part of your notes until you get up to these example problems. So go ahead and pause the video while you have a chance to read those notes, and I'll still be here when you get back. Alright, welcome back. Here we have a few examples on how to use this property of logs and exponents and how they undo each other. Let's look at this first one, the one with the sevens. Here the answer is actually just x, and that's because the bases match. Here I'm talking about the base of the exponential piece and the base of the logarithm. Alright, now let's look at the next one. With log base 9 of 9 to the x. The answer is just x, and the reason is the same as before. The bases match. The base of the logarithm matches the base of the exponential expression inside the logarithm. Now if we look at the next one, with log base 5 of 25 to the x, it's a little bit more challenging. This time, they don't match immediately, so we need to take care to rewrite 25. We can make it 5 squared, and that allows us to then call it log base 5 of 5 to the 2x, using the power of power property. Now, the bases match. The base of the logarithm matches the base of the exponential expression inside the logarithm. Once we have that, we have our answer, which is 2x. Done. Now this last one, 10 to the log of 3x, is included because it's a little bit special, because the log is missing any numbers showing what the base of the logarithm is. And hopefully you recall that whenever that happens, that just means that the base is 10. So if you don't see a base for a logarithm, that means it's 10. Now if you look at it, we have the base of the exponential piece is 10, and the base of the logarithm inside the exponential piece is 10, so the bases match, which means the answer is, in fact, 3x. Alright, now, this is one little set of tricks. It doesn't really have much to do specifically with the rest of today's notes. If you read forward through example 3 and example 4, you'll learn some stuff about how logarithms and exponential functions are inverses of each other. I'll wait a few seconds while you pause the video and go ahead and read those. I'll still be here when you get back. Welcome back. Here we have an exponential equation, y equals 5 to the x plus 3 minus 1. First step to do the inverse function is to do the old switcheroo. That's where we trade the x's and the y's. Now, add 1 to each side, because the minus 1 before is certainly easy to move around. We're trying to solve for y, so we got that minus 1 off of the side of the equation that had the y. Now we're kind of stuck, though, because y is in the exponent. Right here, right now, is where we change the form. Right now it's an exponential form, but using our tricks of logarithms, we can trade it for logarithmic form. We did this a lot, actually, in the last set of notes, but the expressions weren't nearly as complicated then. So here we have log base 5 of x plus 1 equals y plus 3. Remember, when you write it in logarithm form, the exponent is on the other side of the equal sign. Now that we have this, it's easy to solve for y. Just subtract 3 from each side, and bam, you've got your answer. Now let's look at the next one. Y equals log x minus 1 plus 2. First things first, the log is missing a base. So let's go ahead and write it in with the base of 10. Remember, if the logarithm does not have a base, it means the base is 10. All right, now to do the inverse, we'll go ahead and pull the old switcheroo, trading our x's and our y's. Now we need to solve for y, but y is inside the logarithm. So, first things first, let's move that 2 over there. So x minus 2 equals log base 10 of y minus 1. Once we've accomplished that, the y is still inside the logarithm. Now we'll need to trade form. So, from logarithmic form, we will turn it into exponential form. 10 to the x minus 2 equals y minus 1. All right, so again, we took the logarithm and we made it the exponential equation that has the same information. And now we're almost done solving for y. Just add 1 to each side, and we're done. If you go back and you look at both of these, you'll see that when an equation starts as an exponential equation, its inverse will have to end up as a logarithm equation. Conversely, if it starts as a logarithm equation, its inverse will have to end up as an exponential equation. In both cases, when you're doing an inverse, you do the switcheroo, of course, and then you also change the format of the equation, either from exponential to logarithm or from logarithm to exponential. All right, now we've got a couple for you to try. Look at number 1. Give it a go yourself, please. I'll wait so you can pause the video, and I'll still be here when you come back after trying number 1. Welcome back. Hopefully, boom, you got y equals 3 to the x minus 5. Begin with a switcheroo, move the 5, and then, and this is the tricky part today, change it from from a logarithmic equation into an exponential equation. Okay, let's go ahead and try again. Look at number 2. Try it on your own. I'll still be here when you get back. Don't worry about it, you can pause the video. And welcome back. Let's see. Boom. Hopefully you ended up with y equals log base 3 of x minus 5. Pull the switcheroo, then go ahead and move the 5, change it from exponential into logarithmic equations. Okay, so that's one key thing that we're doing today. The next thing will have a piece which relies on your ability to do this here and there, especially that part about changing the format. Go ahead and please read about the graphs. Boom, boom, boom. Here I had an explosion of orange highlighting. Oh well. And then I'll wait so you can pause the video and go ahead and read those parts of the notes, and then I'll still be here when you get back. Welcome back. Okay, now the first thing to know about this logarithm equation function is that because of the x plus 3 inside the parentheses, the graph moves left 3. Because the graph moved left 3, the asymptote is at x equals negative 3. Well, easy enough to draw an asymptote, a vertical line asymptote, at x equals negative 3. Remember, all of our logarithm graphs have vertical line asymptotes. All right, once you know that the domain will be x is greater than negative 3. For all of our logarithm graphs, the domain will be greater than the asymptote. Okay, now the next step is some real work. You're going to need to solve for the x-intercept. Begin by making y equals 0 and substitute in for y. Rewrite the equation. Then you need to solve. Solving for x is not particularly easy, but you'll need to change it from logarithm form into exponential form. That removes the x from being inside the logarithm. Here it's 2 to the 0 equals x plus 3. 2 to the 0 is 1, So 1 equals x plus 3. Subtract 3 from each side. Boom. X equals negative 2. So the x-intercept is at negative 2, 0. Go ahead and make that dot. Boom. I made the dot. Now you can make the logarithmic swoosh. You've got your graph down. The only thing you're left missing is the range. But the range for all logarithm graphs is all real numbers. Okay, here's another one. This time, it's log base 2 of x, wait for it, plus 3. The plus 3 is not part of the logarithm, it's just off on the end. Because of that, the graph is actually moved up 3, but movements up and down aren't actually important to you here, because they don't change the asymptote. So the asymptote is still x equals 0. Knowing that, we can go ahead and draw the asymptote. And then we can move forward about the domain. The domain is all the numbers greater than 0 because it's to the right of the asymptote. Now to solve for the x-intercept, that's some real work. Go ahead and make y equal to 0. But this time, move the 3 first because it's not inside the logarithm. It's just hanging out. So negative 3 equals log base 2 of x. Because x is inside the logarithm, you need to proceed by changing the format from logarithmic into exponential. So 2 to the negative third equals x, but 2 to the negative third is really 1/8. So the x-intercept is 1/8, 0, or if you prefer the decimal version, it's about 0.1, 0. All right, there's the dot. It's a very, well, I guess I was going to say it's a small dot, but all dots are small dots. It's really close to the asymptote. You can still make your logarithmic swoosh, and the range is all real numbers. All right, moving forward. Here we have one last one where I'll take you through step by step. Y equals 1.5 log of x minus 1. This graph is moved to the right 1 because it's x minus 1 inside the logarithm. That means the asymptote is at x equals 1. Boom, there we go, asymptote. Now, because of that, the domain is all the numbers to the right of 1, so x is greater than 1. We make the x-intercept, but before we get too excited about the x-intercept, let's remember, if there's no base written in the log, that means base 10. Okay, now, to do the x-intercept, we'll make y equal to 0. In this case, we have this 1.5 multiplied in front. If you divide both sides by 1.5, you get 0 equals log base 10 x minus 1. Now, the x is inside the logarithm. There's nothing else to do. Change it to exponential version. 10 to the 0 equals x minus 1. So 1 equals x minus 1. So x equals 2. Great. Our x-intercept is at 2, 0. There's the dot. Make your logarithmic swoosh. Swoop. Apologies, Nike, for the trademark infringement. And mark down the range. All real numbers. Okay. I've got one here for you to try. So please pause the video, and when you come back, I promise I'll still be here. Hey, welcome back. I hope you enjoyed trying number 1. Boom. That's all the information you need. So first of all, it moved left 1, so the asymptote is x equals negative 1. When you solve, you put in 0 for y. When you solve for the x-intercept, you put in 0 for y. And it ends up being that the x-intercept is the point 0, 0. There's the swoop. The range is all real numbers. The domain is everything to the right of that asymptote. It always is for logarithm graphs. So it's x is greater than negative 1. Okay, here's another one to try. Again, please pause the video, give it a try yourself, I promise I will come back after you're done. Hey, welcome back. So, let's see here. All right there. This one's a little strange, just kind of mostly in the graphing at the end. It moved left 8. It also moved down 2. The down 2 didn't really matter for anything. Because it moved left 8, the asymptote is at x equals negative 8. And then the domain is x is greater than negative 8. To do the x-intercept, you make y equal to 0. Here you add 2 first, because the minus 2 is outside of the logarithm. Then change it into exponential form, which is 4 squared equals x plus 8. 4 squared is 16. Then you subtract 8 from each side. Boom, x equals 8 is your x-intercept. 8, 0. Go ahead and try to make your swoop. It's a little disconcerting. Don't stress too much about the shape. And the range is all real numbers. Okay, this is not some easy stuff. But hopefully you gave it an effort, and then hopefully you're able to get started trying the assignment. Thank you for your time.